Okay, AP Cactus, AP Computer Science A. This is Unit 2, the multiple choice from Unit 2 in the Barron's Study Guide. So, let's see, there's this big class we're going to use for 1820. This whole page is a class. I'd read through it carefully, see what you have. It's a temperature class. It has private instance variables, string, scale, Fahrenheit or Celsius, just the letter, and double degrees. Constructor with specified degrees and scale. So this is a multi-arc constructor, and so we don't have a zero-arc constructor at least. Mutators converts temperature to degrees Fahrenheit. Temperature to Fahrenheit. So this will change it. Temperature, now it requires that you have a temperature in Celsius before first to use it. Mutator converts it to Celsius. Same idea. Mutator, the amount of number of degrees raised. So this raises the temperature, and the next one lowers the temperature. And then there's a static method that says is valid temp, double, temp degree, string, temp scale. So maybe that verifies that it is a valid temperature. Maybe you need to do that before you do the to Fahrenheit or to Celsius. So 18 says a client method contains this code segment. Temperature T equals new temperature. That seems right. If you look at the constructor, it takes the temperature first as a double, and then the scale as a string. Now you can put an int in for a double. That's fine. You can't do it the other way. So essentially, this is what it does. We could even create a little picture here. I don't know if this will help or not. Sometimes it does. So it has the private instance variables are scale and degrees. So degrees and scale. And this holds a double, and this holds a string. And so we're putting 40 in here and C in here. And T1 references this. Okay, so it doesn't technically equal it, it references it, it connects it. It's connected to its spot, and there you can change things, get things. T2 is now going to reference it. Also, T1 still references. T3 is going to take T2. So this says, okay, take whatever T2 is referencing and lower the temperature by 20, which affects everything that's represented. And now T3 is going to reference it. T4 is going to take what T1 references, which is what all these guys are referencing, and changes it to Fahrenheit. And also, it now references it. So all of these guys are referencing, and these changes impact all of them. Which statement is true following the execution of the segment? T1, T2, T3, T4 all represent the identical temperature in degrees Celsius. Nope, it's Fahrenheit. T1, T2, T3, T4 all represent the identical temperature in degrees Fahrenheit. This is the right one. But let's take a look at the others. T4 represents Fahrenheit temperature, while T1, T2, T3 are Celsius. So that'd be acting like T4 created a new temperature. So there's no, anywhere on here, there's only one new temperature. There's only one temperature object that's been created. If you want to create a new one, like a separate one, you'd have to use the keyword new again and use a constructor. So that one's wrong. T1, T2 refer to the same temperature object. T3 refers to temperature objects 20 degrees lower than T1, T2. So this is acting like they're all separate, but they're not. Null pointer exception thrown, nope. So this picture, hopefully this is kind of helping you understand sort of how these things are connected. So there's only one object. New is only used once, but all these other guys, all these other references to it, I guess they call that aliasing. So alias is like a different name for the same person, right? So these are different references for the same object. Public class temp test. So here's another class, like a client class. Public static void main. So this is a main method. System dot out enter temperature scale, and then we're going to read in a string, and then enter number of degrees. We're going to read in a double. code to construct a valid temperature from user input. Which is the correct replacement for code to construct? So we know we have to create a temperature type variable. We have to use the keyword new, and we have to use the constructor. So that looks good so far. And this says if t is, so this is going to be not, right? T dot, t is right here, is valid. Now, the is valid method takes a temp degrees and scale. It seems like it might be better to check if it was valid before you created it. But, so this is saying if it's not valid, give an error message. But that seems like, oh, okay, here's the other thing. Is valid is a static method, okay? Which means you can't call it on an object. Like you give it these arguments, but this right here, because is valid temp is a static method. So it's just this like method in there to help you do stuff, but it can't be run on an object, a temperature object. You give it the degrees and scale separately, which kind of gives away that you probably wouldn't just run it on that. It seems like it'd be better to do the other way around. But the reason this one fails is because of this issue right here, the T dot. This one says if is valid, so that looks good. We're not trying to run it on temperature object. If it's valid, all right, let's create it. Else, do something else. That one seems good, but let's see. Let's see. No. The only thing, yeah, I don't know. I think to run the static method, you might need to actually put the name of the class that it's in. So you would need to say, I think you would need to say, what you do need to say is, I think you need to say temperature dot. It's kind of like math.random. Random's like probably like a static method in the math class. So temperature, I think you got to put the name of the class that the static method is in. We don't call it on temperature object, but we still got to figure out where it's at. Is valid is not in the temp test class. So Java's not going to know, it's going to say it doesn't recognize it. So that's the main problem there. Now look at the next one. See, if you hadn't caught that, and then you read the next one, you're like, oh, well, this one's saying temperature dot. Does that matter? Yes. So I just discussed it. We need that. So I think this one's good. It's going to be 3 only. So kind of interesting. Figuring out how these work. Let's see, the next problem, 20 says the formula to convert degrees to Celsius to Fahrenheit is this. So give me the formula. For example, 30 degrees would be 186, it would be 1.8 times 30 plus 32. And 1.8 times 30 would be 54 plus 32 would give you 86, whatever. Okay. And in Fahrenheit, Accessor method is added to temperature class. Here's its implementation. So this is in Fahrenheit. It says the temperature is a valid temperature in degrees Celsius, precondition, so you have to give it Celsius. An equivalent temperature in degrees Fahrenheit has been returned. Original temperature remains unchanged. Now, going back and looking at the method before, they had 2 Fahrenheit and 2 Celsius. So I don't know if that's supposed to be, it sounds like the 2 Fahrenheit one. Maybe the 2 Fahrenheit might actually change the value. That's more of a mutator. Oh yeah, it says it's a mutator. So this is different. This is just going to convert it and return it separately, but not actually change its value. So they create a variable inside the class, a temporary variable just for the method called temperature. And then you return it when you're done. So in the meantime, how do you do it? Which the following, so the post condition is achieved. Result equals new temperature, degrees times 1.8 plus 32, and make it Fahrenheit. That seems like that would work, right? You're actually putting the code in there. This one creates it and multiplies by 1.8, which isn't Fahrenheit yet, but then raises it after the fact. So I think that would work. I mean, it seems kind of silly. Why not just do it all together? But that would work. This one takes degrees. Now, the thing about that this is bad is it's actually changing the private instance variable. It's changing the private instance variable, which isn't necessarily a problem in general. I think that the 2 Fahrenheit method probably do this, but they specifically said the original temperature remains unchanged. And now we're actually changing it. So this does give you the correct temperature in Fahrenheit, but in the process, it actually changed the value of the temperature in the object, which it wasn't supposed to do. So that one's out. So I'm going to say 1 and 2 only. So you got to be careful because, I mean, number 3 looks good. It does give you the right number, but it does something on the way that wasn't supposed to. All right, so the next one says public class count stuff. So I think this one's separate from our temperature stuff. Public static void do something. Okay, and there's an integer count equals 0, code to do something, no screen output produced, count plus plus. Public static void main, so this is the main method. Int count equals 0, system dot out how many iterations, like how many times you want to do it. And so you read it in from the user, and then you're going to use that input to decide how many times to do something. So iterations is how many times you want to repeat something. So you're letting the user determine that. And it's going to call do something over and over again, and system.printout ln count. It says if the value of n is 3, what screen output will this program subsequently produce? Now the thing you got to watch out for here is that there's an int count here and an int count here. Okay, this one exists in the main method. This one exists in the do something method. They are not the same. Okay, they are not the same. Okay, so here you put this in as 3, you run do something, and you think that, you know, inside this method count equals 0 at first. You do something and then you print out count, which you would think, well, that's going to print out 0. And then count's going to get incremented to 1. And then we're going to do something and it's going to get printed out. And then count's going to get incremented to 2. And now if it's 3, then that's going to be the last one. So I think some people would probably go with 0, 1, 2. The problem is that this is the thing that you're actually printing out, and it's been 0 the whole time. This is from this class. That's not what, this is the one that's getting printed out. So you got to be 0, 0, 0. Now, I guess I misread this because, well, I don't know. I feel like there should be a 0, 1, 2 option on here, but I don't see it. But it's supposed to be A. So this is a local variable, okay, that only exists while the method is running, and then it actually goes away. Oh, here's the crazy thing, actually. Count is 0. It does something. It increments itself to 1, okay, but then the method is done, and so when you go back to run the method again, count is back at 0 again. And then you do something, it increments it to 1. And then it goes back to 0 again. So really, I think it's going to be, if you were to think of it, you think it would print out 1, 1, 1 every single time. If it was this one. But this is a local variable. And once the method is finished, everything gets reset when you run it again. That's called the scope of a variable. Like, when does it exist? Sort of like its life. Okay. This next one says public class int object. It's just private instance variable num, constructor, another constructor, and then a method called increment. So pretty short class. Here's a client program. class int object test. So it's kind of like a driver, it sounds like. Public static int object some method, and then you have public static void main. So I don't think we've seen this a lot where we have the main method and then another method in the same class. And they're static because we're not going to actually create any int object test objects. So in here, int object creates a new int object with a 2 in it. So that's his private instance variable. And then, so we could draw a picture. I think drawing pictures of these is going to help. So this is an int object, and it has a private instance variable num. And this one is going to have 2 in it, and x is going to reference it. And then we're going to create another one. There's another new one, keyword new. It's going to be a separate object. Int object. It's going to have private instance variable num. This one's going to have 7 in it, and y is going to reference that one. Now, a is going to reference what y references. So a references this object now. And then x is going to equal some method y. So now it calls some method, which takes an int object argument. So whatever y is referencing goes in there. And int object answer equals object. So there's this new int object variable in here, and it gets assigned to what. So while this is running, object is now referencing this. While this method is running, and now answer is referencing the same thing. And then you're supposed to increment it. You run the increment method, which up here adds 1 to the value. So that's going to actually change its value. I mean, we pass these in as values, the references, but they're tied to this object. So if we do something to answer, it's going to affect object A and Y since they're all tied to this object. So then the method is done, right? And by the way, now X is referencing this object. So X is gone up here. This guy, we've lost. We can't even get this guy back because nothing's referenced anymore. Now A is going to take X as an argument for some method. By the way, object and answer cease to exist. But now we're plugging X in there. And so now object is tied to this, and then answer is tied to this. And then it gets incremented again to 9. And then we return answer to A, which, by the way, A is already referenced to that object, so that doesn't do anything. Object and answer cease to exist. So what we have now is that X, A, and Y are all referencing this one object, which is now up to 9. Just before the end of execution of this program, what are the values of X, Y, and A, respectively? The values of X, Y, and A. So I guess the values of their private instance variables or something. I think it's going to be 999, right? Just before the end of execution of the program. Because once the program's over, we just lose it all, okay? So it's going to be 999. Some people would think it might be, X might be 8. I can see some people thinking X was 8. Well, that's not even an option on here. Or X is 9 and Y is 8 and A is 9,989 maybe. I don't even see that on here. But they're all pointing to the same thing. They all have the same value. These pictures are super helpful, I think, for like just understanding how these things work. Okay. Public class tester, public void some method, takes 2 integers, has a temporary integer in here, temp equals A equals B equals temp. So what it's doing is swapping A and B. Okay. But remember, A and B only exist inside this method, and we don't return them. So in another class, I don't think we're going to see any change. So if we call, some method, and we plug this great tester equals a new tester object, which I don't even know. I don't see the constructor here, so maybe there's, I don't know. and then we call this method on it. So we're going to plug in 6 and 8, x and y, 6 and 8. So A is going to equal 6 and B is going to equal 8 inside this program, okay? And then temp is going to equal A equals, which is 6. And then A is going to equal B equals, which is 8. And then B is going to equal what temp is 6. And so they've swapped places. The only problem is that once this program is done, all these stuff disappears. And X and Y are exactly what they were before. We never changed X and Y. Just before the end of execution of this program, what are the values of X, Y, and temp, respectively? I'm going to say 6, 8, and we don't know. 6, 8, 6, 8, and we don't know. We don't know. We've lost temp. Temp's gone. Now, so that's it. Okay. All right. I hope that helped. You get ready for multiple choice final.